So anyways, I want to thank you all for making time to be here. I know all of you have busy schedules, and to be here for 6 hours worth of time is a major commitment on your part. And so I appreciate you making the effort to do this. This is the first of many of these sessions that I'm going to be offering. I've been doing the corporate training thing for the last 10 years now, and I still do a ton of corporate training. But I'm also looking to offer more classes like this, some for free, some for a cost. And this will be the first one that I'm delivering like this. So as we go through the next 6 hours together, I'm going to go ahead and just apologize ahead of time for any technical issues or glitches that may occur for things I just didn't think of ahead of time. So I tried to think of all the things that could go wrong, and I think I have most everything covered. But just in case something does go wrong, please forgive me ahead of time for that. With that said, let's go ahead and actually jump into the course itself. So this class is going to be on Rust for Python programmers. If you are a Python programmer, then you're going to understand the Python code and hopefully be able to relate that code over to Rust. If you are not a Python programmer, well, you may get a chance to learn two languages then in the course of today. So we will be using Python examples to help us understand Rust code, but Python's a pretty easy language to understand. So if you have experience in other languages like a C# or a Java or even a JavaScript, the Python code should be pretty straightforward, and you should be able to relate that over to Rust. The reason why I chose Rust for Python programmers is that the two languages are really, really quite different. There's a lot of Python programmers out there in the programming world, but far fewer Rust programmers. So I thought it would be interesting to take two languages that were so different and to explore how we can use the one language, Python, combined with some AI techniques with GitHub Copilot to be able to learn about Rust. This won't strictly, though, be an AI type of class. We will be just talking about programming stuff too, but you will see Copilot being used throughout to try to help us understand how we can learn other languages using all these great AI tools that we have now. Let me first talk a little bit about training for programmers. So one of the goals here is I want to start delivering the high quality corporate training that we do in the corporate space. I want to start trying to make that training more accessible to individuals. I don't know about all of you, but back earlier in my career, I worked for some great companies on some great projects, but those companies didn't usually invest in training. So any training that I wanted to do, I had to go out and do it myself. However, since I've been in the training world for the last 10 years, there's a lot of really great companies that do invest in training for their employees. But if you don't work for one of those companies, then you miss out on a lot of learning opportunities. So my goal here with these sessions is to kind of bring to everybody else the same type of training that you would find in a corporate environment. It won't be exactly the same because of the large format and stuff like that for the class. It'll be a little bit different, but I want to try to bring a lot of those benefits that people at large corporations see. I want to try to bring that to everybody. And with the power of the internet, there's no reason not to, right? So anyways, that's the goal. For the training classes that we deliver in this format, our goal is to set it up so that you can do everything in a web browser, everything from join the session itself to actually doing the coding. This is one of the reasons we're using Codespaces. That way, anybody in the world with literally any kind of computer, even something like a Chromebook and an internet connection, can participate and be in the training and be able to code along. All of us have sat through webinars and other presentations where all you could do was watch the presenter, right? Because you didn't have a local environment set up. Through the power of Codespaces, modern web browsers, we can actually do that development as well without having to go through a lot of configuration. So hopefully all the code space stuff will work well for us today. The goal for these sessions is to focus on in-demand languages and frameworks. We're going to be looking for the topics and technologies that actually are being taught in the corporate space, but bringing it out to everyone individually. One of the other things that we want to do is help empower people to work where they live. What do I mean by that? There's a lot of people who have to travel around the world to go find a job because they have to be on site or they have to go somewhere to get a certain education. So they have to leave their families, they have to leave the communities they've grown up in, and they have to relocate somewhere else. With the power of the internet, no one should ever have to move anywhere, right? Because almost all this stuff that we do, at least in the technology world, can be done remotely. And so one of my goals here is by delivering the training to where you are, not requiring you to get on an airplane, not requiring me to get on an airplane, we can take this knowledge and share it around the world, okay? The last part is I want to try to incorporate AI tooling into these lessons. I have a very balanced view on AI. I see a lot of potential for it. And I can tell you from my own personal growth and teaching experience, AI has been a very powerful tool to allow me to do a lot more things than what I was doing before. So I want to try to share some of that as we go through our course today and future courses that we deliver. We do have some more upcoming training sessions. We have a class on building web apps with Rust and Leptos. That's coming up on May 2nd. That one does have a price. It's $10. We have 2 additional classes coming up. They're going to be much shorter in length. One is going to be focused in on creating memory-safe applications with Rust. And the second one Can you all hear me okay? Looks like some people are lost audio. You can hear me? I am back. That's not good. Okay, I did not realize I was getting disconnected. Okay, you can hear me again. Okay. So anyways, we have these upcoming training sessions, and each of them will have code spaces and code, and you'll be able to code along and stuff like that. So it should be a lot of fun if you have an interest in signing up. Okay. All right. So what's our agenda going to be looking like today? I set it up for 6 hours. We're going to have lunch in the middle for 30 minutes. There will be 2 15-minute breaks, one in the morning, one in the afternoon. Each session is going to run for an hour and 15 minutes. That'll be the plan. So the breaks and the lunch are set in stone. So at 10:15, we will take that break. So I'll time everything so that we can take our break at that point. So if you do have to step away and you want to come back later on or whatever, you can follow this schedule here. This schedule is also listed in one of the emails that you received as part of registering for the session. The outline summary here for today, I'm going to do a very quick overview of what Rust is. Then we're going to get our environment set up using the code space. That should go pretty quickly. And then we're going to spend the rest of the day just focusing in on going through the various demonstrations and examples that I prepared for you ahead of time. There won't be a tremendous amount of live coding because of our short amount of time together. I actually pre-coded most everything. In my corporate classes that I teach, I do a lot of live coding from scratch, but we have, 5 days to cover the content. But I wanted to make the most of our time here together, so I've done most of it as pre-coded stuff, and we're going to look at those examples. As part of the content, I have created 4 exercises for you to work on. I'm undecided if I'm going to have you do the exercises as an in-class thing, or if I'm going to have you do the exercises as an out-of-class type of, further discovery on your own. I'd like to be able to cover all of the planned content, so I have a feeling the exercises will be something you just do on your own. but I've provided instructions and full solutions and stuff like that. So they can definitely be done independent of today's session. Okay, let's quickly do an overview here of what is Rust. Okay. So Rust is a fast, memory safe programming language that's used for doing system level programming, programming concurrent systems, things like that. What makes Rust different from other programming languages is that, or from other programming languages that most of us use, is that Rust is not garbage collected. It also doesn't have an unmanaged manual memory management system like you'd find in C or C++. Instead, Rust, through its compiler, enforces you to write memory-safe applications. So you don't have to deal with the garbage collector at runtime, but you also don't have a bunch of manual memory management that results in a lot of bugs. Recently, companies like Microsoft have started using Rust in the Windows kernel. Linux is now starting to use Rust as part of the Linux kernel. Even different government agencies and stuff are now promoting the use of Rust over more manually managed memory programming languages like C and C++. And that's because in this day and age of the importance of cybersecurity and attacks on the software that we're running on a daily basis, these memory issues are a real problem. And even though people have worked super hard with C and C++ over the decades trying to make developing with them safe, it's still just so easy to make mistakes, especially if you are a newer programmer. The problem with garbage collected languages is they can have impacts on performance because you never really know when the garbage collector is going to run. Rust kind of bridges that gap. It gives you that memory safety, but it enforces it at compile time, which introduces a bunch of little challenges into how you write your code. Those challenges will be some of the things that we'll be talking about today when going over the code. So 5 quick things here about Rust. It's a systems programming language, but to be honest with you, people use it to build web applications. People use it to build REST APIs. They use it to build utility applications. So while, yes, it is a system level language, you do see Rust being used for things that you might use C# or Java or Python for once you know how to program in Rust. It has its own unique ownership model to manage memory without a garbage collector, as I mentioned. Very powerful type safety and error handling features. In fact, one of the things I love most about Rust is it really forces you to think about handling errors. It really forces you to deal with the concept of a null reference that you might have in other languages. You don't really deal with that in Rust because of the way the language is set up. It provides zero cost abstractions, right? Languages like Python will give you abstractions, but they're not zero cost. Rust gives you zero cost abstractions in most cases. It can be used for a whole wide range of applications, building web servers, operating systems, to actually just building REST APIs or building even a web app. So it can be used for a lot of different things. The last thing I'll mention here about Rust that I want you to think about, yes, Leptos. If you want to check out Leptos, Leptos is building building web applications with Rust that can run server side, but they can also run as WebAssembly in the browser. One last thing I want to mention to you about Rust is I think one of the biggest benefits in terms of my own career development, my own increase of professional knowledge about programming, is that Rust really makes you think about memory. It really makes you think about how memory is being managed within your application. there are going to be things that Rust is going to prevent you from doing that it never occurred to you would be something you shouldn't do. Python lets you do it, C# lets you do it. But when Rust stops you from doing it, you start to think to yourself a little bit about, yeah, how is this memory being managed? Who is allowed to access this memory? It's pretty amazing. So even if you come out of this session and you don't end up using Rust at all, just some of the ideas and concepts you're going to be presented with will make all the difference in terms of how you work with any programming language in the future. Okay. I have a quick question here from one person asking, is there going to be any mention of how you might use Rust to extend Python? Not in this particular class. I do teach classes on things like C extensions for Python, using technologies like Cython and stuff like that. I would definitely be open to having a session where we take a look at using Rust to extend Python. I'll keep that in mind for the future. In fact, I'm really glad you asked about that because I'm going to mention this real quick. As we go through today's content, we're going to talk about a lot of great things. But I am sure there's going to be a lot of things we don't talk about that many of you were hoping we were going to talk about. At the end, I'm going to be giving out a link to a survey. I know we all hate surveys. I hate surveys. But on that survey, I'm going to ask you in one of the questions to list any topics that you'd like me to do future sessions on. So if we don't talk about it today and you want a session on it, that survey is where you can offer me that feedback, and that will help me decide what topics to offer in the future. So kind of keep that in mind as we go throughout today's session. At the end of class, I'll be giving a survey, and that's a great time to offer feedback on future topics. Okay. So with that said, that's the end of the slide deck. We're going to go and start doing some actual Rust coding now. So let me come into here and exit out of that. And let me explain to you what we're going to do here. This is our GitHub repo for the class. It's a public repo. Everybody can access it. This GitHub repo is going to stay up on GitHub basically forever. I mean, maybe at some point GitHub wants to charge money for it and then I pull it down. But for our purposes, this repo is going to stay up forever. So if you want to come back and access this repo after the course is over, you want to come back and generate a new code space and practice some Rust coding, you can come back to this repo right here to do that. So first of all, this is going to be the repo for the course. So I'm going to give everybody a link to this. I'm going to copy and paste this into the chat for you. Give you a second to go ahead and open that up in your web browser. Okay. Next step. I would like everybody who's interested to code along with me as we go throughout the course today. In order to make the setup process super simple, I have set up what's called a GitHub code space. Some of you might be familiar with them. Some of you might not be. Inside of this dev container folder right here is the configuration for the code space. You don't have to do anything with this. I'm just letting you know in case you have an interest in code spaces. This is the configuration. This is where it's located. For us today in the class, what we're going to do is, first of all, make sure you're logged into GitHub with your personal account. Once you're logged in and you have this web page loaded, you can come under code. This is usually what you see, but click on the code spaces tab and click create code space on main. Okay. Now down here, it will tell you who is paying for the code space. Now, before you get worried about that, GitHub gives all personal accounts 120 free hours a month for code spaces. So assuming you're not using 120 hours a month, our 6 hours today shouldn't be a problem, okay? But technically, if you were to go over the 120, it does cost money, but hopefully you haven't gone over your 120. Anyways, you're going to click on the create code space on main, and I'm going to do that right now. And it's going to open up a web browser for you. I do recommend using Chrome or Edge or Safari. Firefox sometimes works okay, sometimes it doesn't, okay? Not that many people use Firefox anymore, but if you are using Firefox, I probably should mention that sometimes it doesn't work as well. Now, as this loads up, let me offer a couple of more comments. The way that I've configured this code space is I created what's called a preloaded image, which means the image for the code space was already built ahead of time. If I had not used a preloaded image, it would take about 20 minutes for GitHub to build this code space and make it live. So make sure that when you click open in code space, make sure you are not doing this on a fork. Make sure you're doing it on this actual repo. If you do it on a fork, it's going to rebuild everything and you're going to have to wait for 20 minutes for it to do that. This morning it was running extra slow for whatever reason. So I decided to go ahead and preload it, and the image has been distributed around the world. So everybody should have pretty quick response time for getting this thing popped up. Once it loads here, it'll take a moment or two to install all of the extensions and stuff that we need. So we'll give it a second here to do that. But once all the extensions and stuff are installed, you should see something like this. Now, I'm sure someone in the class is going to run into a problem setting this up. If you run into a problem setting it up, number one, I'm very sorry. There's nothing I can do about it, unfortunately, because we're not going to be able to help with local setups. But if it doesn't load up for you or it doesn't work, just sit back and watch this like a regular webinar. And then following today's session, you can go back and get this up and running, or even set up Python and Rust locally on your machine and follow along with the recording, okay? Don't spend your whole time trying to fix the environment and then miss out on the training. It would be better just to watch if it doesn't work for you immediately, okay? Now, this environment has everything that we need. It has Python installed. It has Rust installed. I've installed all the appropriate extensions for doing both Python and Rust development, including debugging right here in VS Code. Also, I have set up for us inside of our dev container JSON, I have added in all of my recommended settings for the editor. So the editor is going to work a certain way, certain line lengths and stuff like that. All of that was pre-configured as part of the code space. If you have an interest in looking at the actual configuration, go to the dev container JSON for that VS Code config. Last thing I'm going to mention is Copilot. If your personal account has Copilot access, that should work automatically. If you do not have Copilot access, you can sign up for a free trial and then it will work for you automatically. If you don't want the free trial, you don't want to use Copilot, just ignore whatever little messages popped up on the screen when you first open the code space. Using Copilot is not required for this class. My goal is to show you how powerful Copilot can be, but you don't have to use Copilot to actually take the course. I realize it is an additional paid service, and some people might want to pay that. Some people might not. That's totally fine. But I will show you how it kind of works. Okay, let me walk you through a quick overview of our setup here. So the Python demos we're going to go over, and there's 17 of them, are listed here. There's a number in front of each one, so we go over them in order. There is a corresponding, with literally the same name, so almost exactly the same names, demonstrations of Rust. So for example, demo 1, Hello World, Python lines up with O1 Hello World Rust. So as you walk through, you can look at these different Python examples, and then you can look at the Rust examples. Some examples are going to be a single file. Some examples will be multiple files, okay? In the Python demos, I have put very few comments. In the Rust demos, I have put lots of comments. So I have kind of assumed people here are familiar with Python, so I didn't spend as much time on the Python comments. But on the Rust side, I put lots of comments in the code. And so as we go through each demo and learn new features, you'll see comments on the new things that we learn as part of that demonstration. Before we jump into the demos, the last thing I'll mention here are the exercises. There are 4 exercises. Exercises 2, 3, and 4 have a begin folder. Exercise 1, you're going to create the project from scratch. Each of them have instructions, and then they each also have a solution. So if we don't actually do the exercises today, it's okay. You can go in and work on those yourself as an offline exercise to go deeper into working with Rust and Python. The exercises do build directly off of the demos, but it's not exactly the same for the most part. Few places are kind of the same, but for the most part, there is a little bit of figuring out you have to do to complete the exercise. There's one last thing I want to mention here. Rust, like many programming languages, has like a package file for it. So for example, when we go into Hello World, you'll see cargo toml. You could think of that as like your package JSON from Node.js, or maybe your requirements text if you were working with Python and using pip, or your CS_proj file if you were working in .NET. You will notice, however, there is an additional cargo toml out here in the root folder. I want to mention this folder here real quick because this is really important. This cargo toml folder is where I reference all the individual demos so that the Rust Analyzer plugin here, the extension in VS Code, this is the extension we use for all the Rust functionality that you're going to be making use of. In order for this extension to work properly with all of these individual projects, I had to create this top-level cargo toml file where I reference all those projects. The reason I mentioned that to you is if you come in and start creating additional folders in here of your own projects, the Rust Analyzer won't see them. So you would need to add that folder reference to this top-level file right here. There shouldn't really be a need for you to do that except for exercise 1. But just in case you decide to go exploring, I just want you to know the reason why these Rust projects will work with the Visual Studio Rust Analyzer tooling is because they're listed in this cargo toml file there. Okay, that's pretty much it on the development environment. I covered that pretty quickly. Remember, you can go back to the recording and watch this part again to get another summary if you need one. And of course, you can look at the code in the future when you do that, and that'll help you understand how things are set up. With that said, let's go ahead and let's dive into our actual coding now. So what I'd like you to do is we're going to come into Hello World, and I'm going to open up MainPy. I'm going to come into Demos Rust under Hello World, and I'm going to open up main.rs. For many of our demos, this is what it's going to look like. I'm going to have Python over on the left. We're going to have Rust over on the right, and we're going to do a comparison. As some of the demos get more complicated, we'll have multiple files open, but I'll try to keep it organized so that all the Python code is on this side and all the Rust code is over here, so we can do an apples to apples comparison. And that's the last thing I'm going to one more thing I'm going to mention here is in some of the Python coding demos, I have done things that are not Pythonic, meaning you wouldn't typically write the Python code that way. However, I wrote the Python code that way so it would line up better with how Rust solves the problem. So as you look through the various Python examples and you look at one, you're like, what is Eric thinking here? Nobody would ever write Python code like this. I know nobody would ever write Python code like that. I just wrote it that way so it lines up with the Rust example, okay? So just kind of keep that in mind. The Python demos are geared for learning Rust. Okay, so with that said, let's go ahead and dive into it. Let's take a look here at our first demonstration. So you'll see here, we have the Hello World style program. On the left-hand side, we have a main function that prints out Hello World. You'll notice I have the type hints being used here. As a best practice, I always use Python type hints in my Python coding. If you've never used type hints before, this class will give you a chance to see a bunch of Python demos making use of type hints. So that arrow none is a Python type hint. Down here, I have the standard Python idiom or convention for ensuring that this file is the main program running. It's not being imported into something else. And so I have my little guard here checking for dunder name equal to dunder main. And if this is the main program running, it calls the main function. And then I've got that function there to output hello world. And of course, in Python, comments are written with a hash symbol. Let's take a look at our hello world Rust program. In Rust, we can write our comments with // for a line comment or /* for multi-line comments. You'll also see that functions are defined with the fn keyword, not def like it is in Python. We give the function a name. Rust is a curly brace language. So if you really, really love Python because it doesn't have curly braces, when you get over to Rust, you're going to be back in the world of curly braces. We have a print line statement, hello world. You'll see this exclamation mark here. What that means is that print line is what we call a macro. It's not an actual function in the language. It's a macro that gets expanded. So we have the macro being used there. We're not going to really get into macros or creating macros, but you will see them being used in the code. So every time you see a function call where there's an exclamation point at the end, that means we're using a macro, okay? When we call regular functions, we call them just like you would in any other programming language. We don't include an exclamation point. Now, how would I go about running these two little programs here inside of our development environment? So if I come over to here, you'll see there's a little play button here. I have a choice. I can run this or I can debug it. So for example, if I just hit play here, it'll open up the terminal window and it runs. If I set a breakpoint and click on Python debugger, debug Python file, it should run and hit the breakpoint and you have the regular debugging tools. One of the reasons I wanted to give you a code space was so that we could have these types of tools without having to lose time setting them up ahead of time. Over here for the Rust code, the way you're going to run the Rust code is the Rust analyzer puts this little decoration above the function. You can click on run, and it will actually go through the process of compiling and running the code. Or you could set a breakpoint, well, breakpoint there, click on debug, and it will also allow you to debug the Rust code. So in this one code space, you can do Python and Rust development and debugging. Okay. Now, let's take a look at using a little bit of AI here. For the AI parts of the course, I did not script these out ahead of time. One of the things I do, so I teach a lot of GitHub Copilot. Like I've probably done, I don't know, maybe 30 or 35 sessions for my corporate customers on GitHub Copilot in the last 60 days. I teach a lot of Copilot. The thing with Copilot, what makes it amazing, is that you can talk to it just like a person, and it's immediately helpful. So whenever I do sessions like this, where we're going to use Copilot, I don't sit down and script out the prompts ahead of time, because when you're doing your programming in the moment, you're not generally scripting out a bunch of prompts. You're just talking to Copilot and asking it a question. So we're going to try to make this as real world as we can in terms of my interaction with Copilot with these demonstrations. From time to time, I will do a bad job asking a question, or Copilot will do a bad job answering the question. That just happens. So as we go through this, if the output or what we're looking for isn't quite what I was hoping it was going to be, that's just the nature of doing real world development and using generative AI. But I want you to see what it really looks like. Anybody can script something. I want you to see what it really looks like to work with it. So what I'm going to do is I'm going to come over here and I'm going to highlight this code. And I'm going to come over to the chat and I'm going to ask Copilot to do the following thing. I want it to take the selection, convert this code to Rust. Probably the quickest and easiest way to get started learning Rust as a Python programmer, okay, is to go to Copilot, point it at some Python code, and say, "Give me the Rust version of this." So I don't, and this isn't even limited to Python and Rust. This is really true for any language. If you know a language and you want to learn another language, start with the language you know, and you can start with Copilot and say, "How do I write this code in this language?" And it will give you the answer. Now, obviously, Hello World is pretty simple, but as we go through this, you're going to see that it can do it for very complex things as well. Another reason we use Copilot is not just to convert code, but to be able to ask questions about the code. Okay. Now remember, Copilot is generative AI. It is not the authoritative source on anything. Talking to Copilot is like talking to your friend. When you ask your friend a question about programming, they're probably right 95% of the time, which means that whatever your friend tells you, you're probably going to have to double check it occasionally, because your friend's not going to have perfect knowledge. The same thing is true for generative AI. Don't hold Copilot to the expectation of it being perfect, but it is so good that it's right probably 98% of the time. And it's a great way to ask context-specific questions to get you up and running faster. So for example, what if I wanted to run this program over here? I could ask Copilot, how do I run this Hello World Rust program? And it's going to give you instructions in general for how you would run a program in Rust. Now, in this case, it's going to have you use the actual Rust C compiler. We're using the Cargo package manager to build and run the project in this class. But you could see it gave you some basic instructions to get up and running. Now, of course, everyone's thinking, well, Eric, I could go to the Rust documentation for that. You could, but that means you'd have to leave your editor. You'd have to go search on the web, get distracted by something. Here, I was able to ask the question within the environment that I'm working in, within the context of what I'm working in. Okay, so kind of keep that in mind and don't underestimate the value of that. Many of us, right, have gone to search for something on the web, and along the way, we get distracted by social media, we get distracted by the news, whatever. And what was supposed to be a quick lookup, an hour later, we get back to coding. So one of the biggest benefits of Copilot is doing this in the editor. All right, let's see here. Got a question here. Are all Rust functions actual functions like in Python, or does Rust differentiate between functions and something like procedures? No, everything's a function in Rust. That's a great question. In fact, that's a question we could actually ask here in Copilot. So in the Rust programming language, are there two kinds of subroutines, such as functions and procedures, or is everything a function? Now, it might come back and say some things are functions and some things are macros. It might mention that. But it tells you everything is a function. Rust does not separate the concept of procedures. See how easy that was to ask? I didn't have to search through a bunch of documentation. Now, of course, at some point, do I want to ultimately verify my knowledge against the official docs? Sure, absolutely. But this is a great way to ask those kinds of questions. Great way to ask those kinds of questions. Okay, so with that said, let's move on to our next little demonstration. So probably one of the first things that we want to do when we start writing program is to be able to provide input to that program, right? If it's a web page, you want to interact with the rendered page. If it's a program that processes data from a database, how do you read data from the database? We're going to take a look at how to capture console input from a program. As you all know, in Python, this is a pretty easy thing to do. Python has an input function. It's typically set up to read from standard in, and you can run this code. Come into here, I'll type in my name, which is Eric. Hello, Eric. And that's it. Pretty easy to do, right? Okay, let's take a look at the Rust version of this code. Okay. Now this code will look longer because I've added lots and lots and lots of comments to it. So it is going to be longer, but it looks a lot longer because of all of the comments. But I wanted to put the comments in there so when you're looking at this code in the future, you can remind yourself what all of these little language features are, okay? Now, before we look at the complexity of this with Rust, it's important that I remind you why we're using Rust. Sometimes when things get hard, we forget why we're doing them. And so that causes us to get frustrated and to become discouraged. And I don't want you to be frustrated or discouraged. The reason we're learning Rust is to do memory safe programming without a garbage collector. The end result of that is we should end up with much faster, better performing code. Python has a garbage collector. Python is notoriously slow. That doesn't mean Python's not good for a lot of things. It actually is good for a ton of stuff. But if you really are trying to build a program that's going to run really fast on your hardware, and you want it to be memory safe, right? So you're not going to use C or C++. Rust is going to be the language that you're going to be looking at. So as we get into the complexity, just remember why we are here. So first things first. Up here, we have a use statement. The use statement would be similar to an import in Python, the from statement, import statement in Python. Now, in Python, the input function is what's called a built-in. It's just available without having to bring in any extra modules. In Rust, if you want to capture user input, we're going to have to bring in additional modules from Rust standard library in order to do that functionality. So you have a little bit more code up here at the top where You have to bring in the functionality, but you also have to know which functionality to bring in. The way that we access standard in and standard out is through standard IO here. And we're also going to need this write trait as well. I'm not going to say a whole lot about traits here at the beginning of the course, but as we get into stuff later on, assuming we have time, I've got content on talking about traits, even creating our own custom traits. Well, let's go ahead and take a look at the main function here. So first, you see where I'm going to declare a variable called name. In Python, you simply assign to a variable to declare it. In Rust, you declare the variable with the let keyword. So the let keyword is used to declare variables. In Rust, variables are immutable by default. The mute keyword, M-U-T, that keyword is going to allow me to mutate that variable. Why do I want to mutate it? Well, we're going to use that variable to hold the value typed in by the user. So we initialize it as a string to begin with, and then we're going to populate that variable with whatever the user types in. So we have the mute keyword. The mute keyword is a key part of this memory safe programming, as you're going to see. But for right now, just think of it as this name variable. We'll be able to change the value of it when we type in the name. Line 18, you'll see we have a print exclamation. I removed the print line, the actual ln at the end, because I want to type the name on the same line as where the prompt is. Now, one thing we have to do in Rust is that before I go to capture the actual information from the user, I need to tell standard out to go ahead and flush. So when we tell standard out to print here, that doesn't necessarily mean that standard out has written everything to the console. So we have an extra command here to flush out anything that's still in the buffer before we go to capture input from the user. I'll talk about the unwraps here in a moment. Then we're going to use standard in, and we're going to read in the data from the user. Now, if you'll notice here, I'm going to pass in what's called a mutable reference. The mutable reference is basically going to give a reference to the string that we created, but it's going to give that reference in a way that this function is allowed to actually change the string value. You see, in languages like Python, if you have a variable, you can pretty much change it however you want to, anytime you want to. But in a Rust program, there's a lot of control over who can read the variable, who can write to the variable, who owns the variable, all that kinds of stuff, because it's memory safe. And all of these protections are built into the compiler. Probably the hardest thing about learning Rust is learning how to set up these variables, how to pass them around. What does it mean to own the variable versus borrow it? All of these things we're going to talk about today, but this is really the hard part of working with Rust, is this memory safe. But once you understand it, not only will it enable you to write Rust programs, but it'll change everything about the way you look at memory management in the other languages that you work with. So for the moment, we understand that readline is going to take user input and populate the name variable for us. We're then going to call the trim function on name, and it's going to remove the leading and trailing white space. You've seen that in other languages before. But this might look a little weird. It's like I'm re-declaring the variable. One of the things that that Rust does is Rust will let you redeclare the variable within the same scope. Why? How many of us before have written code like this? Maybe we have name input. We come down to here, we call it name input. And then we come into here and do name input. And essentially, we had to create two variables here, okay, because for whatever reason. But in reality, it was really just the same variable, just a slightly different kind of value or a slightly transformed value, right? Rust, instead of making us have 10 different variable names for basically the same thing, Rust allows us to redeclare the variable within the scope. So for example, this variable here has a type of string and it's mutable. This variable down here has a type of a string slice and is not mutable. Same name, different variables. So when we said let name, it basically replaced this one with a new one. And then, of course, we're assigning the result of the expression here. I'll be talking about strings and string slices as we go throughout the course. In Python, Rust, there's two ways of working with strings. One is as a actual string that you can, mutate and change, and it's an actual string object in memory. The other is a string slice, which is just a reference to a string in memory. You can't change it or anything like that. So essentially, name.trim returns a slice, and then I can utilize that slice in here. And you'll see the curly braces there. This would be similar to the F string in Python, and it will do string interpolation by taking the name value and putting it here inside the string for us. Now, what's going on here with the unwrap? Well, the unwrap that you see here is part of Rust's error handling mechanism. What if the call to flush fails? What if the call to read line fails? Well, what do? How do I handle that error? Languages like Python, you can choose to do a try-catch, but how many people really put a try-catch around an input statement? Probably very few. In Rust, you don't have the option of trying to ignore the possibility of an error. You have to think about it and handle it in some way. Now, the unwrap here is actually not a good way to handle the error. However, if you look for Rust code online, you're going to see everybody using unwrap, especially in example code. What unwrap basically means is to get the result of this operation. If it was successful, return the successful result. If it was not successful, then panic and the program dies. There's other better ways to handle these kinds of errors other than just killing off the program. But that's what unwrap means. So when you're online looking at code demonstrations, okay, online, and you see unwrap being used, understand that the programmer is using that as a shorthand to basically kill the program if there's an error. But in a real program, if it's a recoverable error, you would write other code to handle that. And we'll take a look at a little bit of that here in some of the future demos we're going to do. Okay. Okay. Before I move on here, we'll get a question here. We're not going to be really talking about how to work with cargo files other than just simply a cargo file is created. We install some crates and they get listed. But that's all we're really going to talk about in terms of cargo files. If that's a topic you'd like more information on, put that on the survey at the end, and we can see about doing a session for that in the future. Thank you for asking. Okay, awesome. So let's take a look at our next example. I actually wanted to do a quick discussion here on the error handling. The error handling won't be a big thing in the remaining demos because it does take up a lot of space in the code base and there's a lot of decisions you have to make. And I want to make sure we cover other features as well. But I thought because the error handling here is so important and kind of unique to Rust the way that it does it, I wanted to do a quick example here for you of looking at some error handling in Python and then comparing that error handling to what it would look like in Rust. I mentioned to you a few moments ago that probably almost nobody would wrap a try catch or try except around an input function call. But it turns out if you come into here and hit Control D, you actually can raise an EOF error in the Python code. So if I hit Control D, handled the end of file error. Who knew? So if I did not have that try except there, then the code would have ungracefully just failed, right? So what if, or what would it look like in Rust to implement similar functionality? All right, so here in Rust, see how it gets a lot more complicated? So first of all, we have the same use statement at the top. We have our variable being declared. We have our please enter your name. The first error that we have to handle is the flush. Notice there's no unwrap on this. One of the things you're going to learn about Rust is that Rust makes excellent use of enums. I don't know about you all, but in all my years of programming, I have actually found very little use for enums in other programming languages. Take C#, for example. Enums are there. I'm not saying I've never used them, but generally speaking, I haven't leveraged a lot of enums in my code. Based upon the programming that I've seen other developers do, they don't leverage a lot of enums either. But languages like Rust are starting to bring back the enum and use it in some very smart ways. For example, in most programming languages, if you were to call a function, you'd have two possible outcomes. One outcome would be a return value. The second outcome would be to raise an exception. So return the value, just return it back. Raise an exception, you have to write extra code like a try except block outside the function to handle that. Also in other programming languages, we could call a function and we could get back a return value, or we could get back none, null, something like that. These two situations actually cause a lot of issues in the other languages that we work with, like Python. By a show of hands, if you could raise your hand for me, raise your hand if you've ever gotten frustrated with writing code that has null references that's returned. And generally it gives you a real object, but sometimes you get the null reference, and then some of the new modern versions of languages, they put in all the null checking and stuff like that. It's a real pain to work with. Rust doesn't do that. With Rust, for this particular scenario, it returns back something called an option. And the option can either be you get a value or you don't get a value. For this situation, it uses what's called a result. Well, the result has two values, error and OK. But what's cool about this is that through the enum, it passes back data. So not only does result give us either the OK or the error, but it actually, through the enum, gives us the value or whatever the actual error message is. So it's enums being used in place of having to worry about, let's say, null references or having to worry about exceptions that you have to catch, right? Instead, you get back an enum, and baked into whatever enum value is returned is the ability to pass through data. And that's what you see down here. We're using the match statement, which is what's using what's called pattern matching. For those of you who are using recent versions of Python, you might be familiar with the match statement in Python. This idea of pattern matching has been showing up in other languages like Python, like C#. We're going to use match here to call flush. Flush returns the result enum. If we have an error, then we can decide how to handle that error. If it worked out okay, then we can decide what to do next, which in this case is going to be to call the read line. If the read line works out, we'll have the output that we have here. If it fails for whatever reason, we can have it here. Now, this is just a way of handling errors. There are many ways you can set this up. Some use the match statement. Some use other variations of unwrap. I gave you this example here, not because we're going to exhaustively cover all the different ways, but I wanted you to see this concept of how these enums are being used in Rust in a very different way than maybe you've seen used in other programming languages. So if you're thinking to yourself, hey, I want to switch from Python over to Rust, or C# over to Rust, or Java over to Rust, one of the things you'd want to go deeper on is learn more about how enums are used in Rust in this very unique but awesome kind of way. Anyways, if we go to run this code here, we'll click run here. I'll hit the, I don't think I can actually really trigger the error with Rust, unfortunately. Yeah, it didn't really work out. The problem with Rust is because of the way the input is done internally, it's hard to really trigger it from the keyboard. So you can look at the code there, but you won't be able to cause the error like we did over on the Python side. It wasn't for lack of trying as part of my preparation. It just, the way it works, you just can't really just trigger it by doing a keyboard combination. Okay, so let's go ahead and let's move to our next demonstration. We're going to take a look at how to handle some numeric input. After this demonstration, we should be taking that first break. Okay, so here for our num input function, we have a return value of int. I'm going to capture input from the user, convert it to an int. If that conversion fails, I'm going to handle a value error. And then down here, we're going to call num input, add the two numbers together, and then print them out. Okay, no big deal. I'll run that real quick. We'll type in 2, we'll type in 3. The sum of 2 and 3 is 5. Let's take a look at what this program would look like in Rust. All right, so remember, the comments do make it look longer than it is, but it is going to be more involved than what we see in the Python code. So let's do a comparison here of our num input function. So far, we've just had the one main function, but now we're going to have another function that we're going to call from main. So here, def num input, function num input. One nice thing about Rust is that if you do utilize Python type hints, the way that types are defined in Rust is a similar kind of syntax. So if you learn Rust types and then you go back to Python, you can apply the same kind of syntax over there. Or if you learn type hints in Python, it can help you in becoming comfortable with the syntax over in your Rust code. Okay, so num input, same basic pattern as before. We create the string, put out the prompt, do the flushing, do the reading. And then down here, we're going to parse this out. So we're going to take the input parse it, and then return the value back. You will notice that I'm using an expect here instead of an unwrap. Once again, this is another alternative to error handling. If this were to fail, this will be the error message that's outputted for it failing. It'll still panic, it'll still end the program, but I'm customizing the error message. When I said unwrap before, that would end the program if it failed, but you don't get to customize the message. By using expect, I'm able to customize the error message that's generated when it fails. We're not going to try to fail it or anything here, but just understand that's what the expect is doing. So num input, we come down to here. We call the num input function, just like you'd call a Python function. We come down to here, we create a variable called result, assign num1 plus num2. And then down here, you can see where we're doing our interpolation to output those values there to a string. So if we came into here and we were to run this, there's our sum right there. Okay. All right. So not too bad. We got a question here. I have not tried checking to see if the various cloud providers have actual SDKs for Rust. I want to say last summer, I was trying to integrate Rust into something. And I remember they didn't have a Rust SDK. I had to make basically REST API calls to be able to call those APIs. You're not going to find, you're not really going to find a lot of Rust SDK for things out there. But these things that do have REST API endpoints, you can make use of those. Okay, cool. So the OK enum itself is what exposes the value. So that's a great question. So if I come back over to error handling here, and I'm going to drag this over here for just a brief moment. When I use the match statement, the match statement matches on the actual result of flush. The actual return value of flush is a result type that is either an error with a value or an OK with a value. So you'll see here in the match, I have to unpack that myself. Over here, when you use the expect or you use the unwrap unwraps that for you and just gives you the OK value. You don't have to unwrap it yourself. That's the point of unwrap. Unwrap unwraps the OK enum and gives you the value back. Here in the match, I had to do the unwrapping as part of matching the OK. All right. Awesome. Great questions, by the way, everybody. All right. So let's see up here. Yes. So you have to read the data in as a string and you have to convert it to the integer. So, so when you're working with console input, all of that comes in as a string, and then you have to do the conversion. We do the same thing over here in Python, right? We receive the input as a string, and then we have to convert it to the integer. Okay. All right, very good. Okay,